Okay, let's look at section 1.7, compute with scientific notation. Now this is something that you're going to use quite a bit in your science classes as you move through high school, so it is important that you understand it. And while it is going to seem a little difficult at first, if you follow the rules and you follow the steps I give you, it will become easier each time you do it. So we are going to need to practice a little bit to get it right. One thing that we need to think about is the fact that we've already studied scientific notation and we know what the answer needs to look like. We can only have one number to the left of the decimal point. It has to be greater than or equal to 1 and less than 10. And that will help us a little bit in understanding what we need to do. So first we're going to add or subtract with scientific notations. To do this, we've got some steps to follow. We have step 1. Step 1, the exponents must be the same. It's very important that the exponents are the same or we can't add them. So we're going to use what I call LARS, left add, right subtract, to move the decimal and change the exponent if necessary. And then step 2, we're going to add or subtract the numbers and keep the common exponent. So let's take a look at this example. We have 6.89 times 10 to the 4th plus 9.24 times 10 to the 5th. Well, they have different exponents. One's a 4th and one's a 5th. So we're going to change the second one, 9.24 times 10 to the 5th, to the 4th. Now I want you to remember, left add, right subtract. Okay? So if we need to have a smaller exponent here, we're going to have to move our decimal point over to the right one place. So 92.4 moved our decimal point to the right, so we're going to subtract 1 from our exponent. So right, subtract. So now we have 6.89 times 10 to the 4th plus, didn't leave myself much room there, 92.4 times 10 to the 4th. In order to add these numbers, when we add decimal points, we add decimals, we have to line up our decimal points. So we have 92.4 and we're going to add 6.89. Here we can put a 0 because it doesn't mean anything, it's just a placeholder, and then add them. So 0 plus 9 is 9, 4 plus 8 is 12. Let's go ahead and bring our decimal point down. Carry the 1. 1 plus 2 is 3 plus 6 is 9. And then we have 9 here. So 99.29. So what we've done is we've taken 6.89, we've added 92.4, and then we've multiplied it times 10 to the 4th. Okay, so we take our two factors out, 6.89 and 92.4, we added them, 99.29 times 10 to the 4th. Now, we know from working with scientific notation in the past that we cannot have an answer of 99.29 because when we have that answer, this number is greater than 10, and we know that we can only have one number to the left of the decimal point, and it has to be less than 10. So this time we're going to take our decimal and move it 1 to the left. Looking at the top, if we move to the left, we add 1 to the exponent. So 9.929 times 10 to the 5th. Okay, I know it seems difficult. I want you to follow the steps and work along with me so that we can go through them together in class. All right, down below it says, why do you need to rewrite 9.24 times 10 to the, change that to the 5th, as 92.4 times 10 to the, change that to the 4th. So it should now read, why do you need to rewrite 9.24 times 10 to the 5th as 92.4 times 10 to the 4th? Well, we have to do this because our exponents have to be the same. So our exponents must be the same to add. So that's the reason why we did it. Second question, why is 99.29 times 10 to the 4th not the correct answer? Well, we know that that is not written in scientific notation. In order to be written in scientific notation, we can only have one number to the left of the decimal, and that number has to be greater than or equal to 1 and less than 10. So that's the reason why 99.29 times 10 to the fourth is not the correct answer. How do you rewrite 99.29 times 10 to the fourth in scientific notation? Well, we did that together. We can only have one place, so we had to move our decimal point 1 to the left. Okay, so we did that, 9.929. And when we do that, we have to add 1 to the exponent. So when we do that, we get 9.929 times 10 to the fifth. Let's continue on with some examples just to help us to practice and see if we can figure some of this out. All right, let's take a look at the next example. 7.83 times 10 to the eighth minus 11,610,000. Well, the first thing I have to do here is I need to rewrite 11,610,000 in scientific notation. I'm just going to write SN for scientific notation. If you want to write over here so you know what that means, we can not have to write it so many times. Scientific notation equals SN. So if I have to rewrite that, I'm going to take my number, and we have a decimal point here. Remember from our last lesson, we're going to move it 1, 2, 3, 4, 5, 6, 7 places in order to get it in correct form. So 1.161 times 10 to the 7th, because this was a positive number, or I'm sorry, a number greater than 1. So now we'll take 7.83 times 10 to the 8th minus 1.161 times 10 to the 7th. Now, in order to subtract, remember that our exponents must be the same. And so we're going to take our larger one here, 7.83 times 10 to the 8th, and we're going to change it to an exponent of 7. In order to subtract 1 from our exponent, remember we have to add or move our decimal point to the right. So when we move our decimal point to the right, we get 78.3 times 10 to the 7th, because we're going to subtract 1 from the exponent, minus 1.161 times 10 to the 7th. Just remember, LARS. I move my decimal point 1 to the right, and if I go to the right, I subtract. So then I'll take 78.3 minus 1.161 times 10 to the 7th power. Let's just show our work over here. We have 78.3. Remember, with decimal points, subtracting or adding, we're going to line them up, 1.161. We can put zeros in for placeholders. 10 minus 1 is 9. 9 minus 6 is 3. 2 minus 1 is 1. 8 minus 1 is 7. So we get 77.139 times 10 to the 7th. But when I look at that, I know it's not written in scientific notation, so I have to move my decimal point to the left. When I move to the left, remember left, add, so 7.7139 times 10 to the 8th. Okay, when you move your decimal point to the left, you add 1 to your exponent. So what do you need to do first to subtract the numbers? Well, first I had to rewrite 11,610,000 in scientific notation. Second question, are both factors multiplied by the same power of 10? No. So we had to rewrite one of the numbers so that they have the same power. Or the same exponent. And I answered my next question, so we could have rewritten that down here. That's all right. Is 77.139 times 10 to the 7th power written in scientific notation? No. It had to be rewritten. As 7.7139 times 10 to the 8th by moving the decimal 1 to the left and adding 1 to the exponent. Now, don't worry if this still seems to be confusing. We have a long way to go. We're going to spend some time working on this together, but do make sure you get down the notes and try to review them and see if you can make some sense out of LARS. Move left, add, move right, subtract, and just think through what you know about scientific notation. All right, let's take a look at the next page. On the next page, we're going to multiply or divide with scientific notation. For this, we have 3 steps. Step 1, we're going to multiply or divide the factors. Step 2, we're going to use the product rule or quotient rule to change the exponent. So remember, product, we add the exponents. Quotient, we subtract. And step 3, we're going to use LARS, L-A-R-S, to move the decimal and change the exponent in the answer if necessary. Okay, for sake of time here, I'm going to use a calculator, and we will start to use the calculator as well soon, now that we're starting to get integers. But I'm going to use the calculator. I'll still show you what I'm doing, but I'm going to check my work with that calculator. So for an example, 7.2 times 10 to the 3rd times 1.6 times 10 to the 4th. Step 1 says we multiply or divide the factors. So here we're multiplying, and the factors are 7.2 and 1.6. So 7.2 times 1.6 and then we have times 10 to the 3rd times 10 to the 4th. All right, so 7.2 times 1.6. Now, remember when you're multiplying decimals, they don't necessarily line up. Here they did. 2 times 6 is 12. Carry the 1. 6 times 7 is 42, plus 1 is 43. 1 times 2 is 2. 1 times 7 is 7. 2, 5, 11. So we have, to the right of our decimal, up here in our problem, we have 2 places to the right of the decimal point, so we need 2 places to the right down here. So we get 11.52. And then we're going to have 10 to the, remember when we multiply these, we're going to add the exponents. So 10 to the 3 plus 4. So we get 11.52 times 10 to the 7th. But is this written in scientific notation? No, we have 2 places to the left of the decimal point. We can only have 1. So we're going to move our decimal 1 place to the left. Remember, when we move to the left, we add to the exponent. So 1.152 times 10 to the 8th power. So we move the decimal left. We added 1 to the exponent. All right, our first question is, what properties allowed us to move and regroup the factors in the expression? If you think back to our discussion about properties in our first unit, you will recall that we discussed the commutative and the associative properties, and these are the properties that allow us to move those around and regroup them and still get the same answer. When simplifying 10 to the third times 10 to the fourth, do you add, subtract, multiply, or divide the exponents? Well, we know that we add the exponents because we are multiplying monomials. And we learned this in section 1.4. Okay, so if you need to go back and review 1.4, this is something we've been doing since the very beginning of the year with our math minutes, but if you need to review it, that's where you would find it. All right, let's move to the last page of our notes. This time our example is a division problem. And on that division problem, we have 2.7 times 10 to the 5th divided by 2.4 times 10 to the 4th. In order to do the work on this one, we're going to divide 2.7 by 2.4. On these, I will allow you to use the calculator. It's just going to make your work a little bit faster. So 2.7 divided by 2.4 is going to be 1.125. So then we have times 10 to the 5th minus 4 because we're dividing. So times 10 to the 1st. And here everything is written in perfect form. So we really don't need to change anything around. It's all written as it should be. All right, I want you to take just a minute, pause the video, and try your best to do numbers 1 and 2 and see if you can come up with an answer on those, and then bring those to class tomorrow so that we can go through them. Also, just take a look at number 3 and see what you think. And I do want you to try it. Now remember, you're not getting any credit for your notes if you don't try these 3 practice problems. So I want you to try them and then bring them back to class tomorrow so that we can work on them together.